In the last session we started with the delta method, and we obtained for delta method an equation of a circle wherein we have actually two different state variables defined for the system, x1 dot equal to omega naught x2 and x2 dot equal to minus omega naught of x1 plus delta, where delta will be a very increment, where will be a small change in the state variable x1. So using C as the center, R as the radius, we draw an arc and we keep on shifting this depending upon the value of it depends upon the value of x1, x2 and time t, and while this arc is completed we'll get the phase trajectory of the system. Now let's take an example. So using delta method we have to draw the phase plane trajectory now, and our nonlinear system here is defined by the equation x double dot plus 25 0.1 x square plus 1 times x equal to 0. So assume this is the part of the question. Assume x not equal to 3 and x2 not equal to is x1 not equal to 3 and x2 not equal to 0. So our equation here is x double dot plus 25.1 x square plus 1 times x equal to 0, and what we can do is, which becomes x double dot plus 25 x plus 0.1 x cube equal to 0. We can compare this with an equation x double dot plus 25 x plus delta equal to 0. So we have written this in this form. This is the form that we have actually obtained yesterday. X double dot plus omega naught square x plus delta equal to 0, where omega is the natural frequency of oscillation. Here omega square will be equal to 25, so you can say omega is actually equal to 5 in this case, and here we have assumed that delta is equal to comparing with this, delta is equal to 0.1 x cube, omega square equal to 25. So taking the two state variables for the system x1 and x2, where x equal to x1, fine, and x dot equal to x2 by omega n, x1 dot is equal to omega naught times x2, so we have these two state variables. Therefore delta for us here is what? Delta is 0.1 x cube that means actually x.1 of x1 cube. Now we know that initially x1 naught is equal to 3, therefore the initial value of delta will be equal to 0.1 into 3 cube, that comes out to be equal to 2.7. So we can write x1 dot equal to x and x2 dot equal to x1 dot divided by omega n, or x2 by omega n. For the system, what we have seen is that the initial delta is equal to 2.7, and we have also seen that for a general system the center is minus delta 0, therefore first center is minus 2.7 comma 0. Now if we want it, if we have if we draw phase plane axes, so the first center is minus 2.70. Now what will be the radius of the system? So we can actually find out the radius of the system as well. Instead of doing that, we can directly say that since x1 naught and x2 naught are 3, 0, this point is 3, 0, so therefore taking this as the first point, we can draw an arc with having a radius of 5.7, and so now we have the center at minus 2.70, and our first point is 3, 0. That is actually being given to us in the question itself. So using this as the center, using C as the center, and let us name this point as P, draw an arc. So for example, this is our arc. We'll draw we'll draw a small arc until we reach another point, say for example P dash. Now what do we do at this point? At P dash we have different value of x1 dash, we have different value of x2 dash. Fine. We already know what is delta. Delta is 0.1 x cube. So at this point, say for example P is equal, x1 is equal to instead of 3 it is now say for example it is 2.9. So this is becomes delta becomes 0.1 into 2.9 cube. So that is 2.4389. So this is delta dash now, 2.4389. So the center has shifted from minus 2.7 to minus 2.4. So C dash is now minus 2.4 comma 0. So this is our new delta, and using this center now and this as this P dash as the point, we'll draw another arc until we reach x1 double dash, x2 double dash. So at this point at P double dash, where the values of x1 are x1 double dash and x2 double dash. Now say for example again x1 double dash is 2.85. So delta double dash now becomes 0.1 into 2.85. cube, 2.85 cube. So this is 0.1 into 2.85 cube. So that's 2.314. So our C shifts again to C double dash, where at C double dash is actually 2.314 comma 0. So now with this as the center, P double dash as the starting point, draw an arc, and that will go like this. So this process will now continue, and you will get a phase trajectory of this for this system. That was described by the equation x double dot is 25 times 0.1 x square plus 1 x equal to 0. So that's one example on the delta model, how to actually construct a delta model. You can use proper you can use graph papers extra to make a proper plot and complete this phase trajectory. Now this P double dash, you take small arcs. Now there is no defined rule about how big this arc can be. It is up to you to decide, and accordingly change the value of C and keep on sketching this plot. So for example, we have another equation here. Draw the phase plane trajectory for x double dot plus x dot plus 2x plus x square equal to 0. We have been given again in this question x10 is equal to 3 and x20 is equal to 0. So taking x1 dot equal to x2 and x2 dot equal to omega naught x2. x1 dot equal to omega n x2 and x2 dot equal to omega n minus omega n rather x1 plus delta. So for this equation, if we actually need to put it in a form that is that we had obtained here. X double dot plus omega naught square x plus delta equal to 0. So what we have here is we have x double dot plus x dot is actually x1 x1 dot, that will be omega n times x2 plus 2x1 plus x1 square equal to 0. So we can this equation therefore becomes x double dot plus, instead of having x dot here, we can say this is omega n x2 and plus 2x plus x square equal to 0, which implies x double dot plus let's say 2 is outside, x plus omega n x2 plus x square by 2 equal to 0, which actually is comparable with x double dot plus omega naught square x plus delta equal to 0. Now delta here in this case is omega n x2 plus x square divided by 2, where omega n will be actually under root of 2. So you can put under root of 2 here, x2 plus x square divided by 2, and this is our delta now. So using this delta, our initial value is given to us. x10 is 3, x20 is 0, so our delta 0 will be equal to under root of 2, x2 is 0 plus x square is 3 square divided by 2, this is 4.5. so when we draw the phase plane trajectory, x10 is 3, 0, and our center is minus 4.5, 0. So using this as an equation, draw the trajectory in this direction. So we'll get an arc, and after x1 will be, say for example 2.9 now, and x2 will be, say for example 0.1 or whatever. Now you have to make sure that when you switch delta, there is both x2 as well as x1 now, so delta will vary in both ways. So at this point, say for example at this point x1 is 2.9 and x2 is 0.3, so delta will therefore become, delta dash will now become root 2 into x2, that is 0.3 plus 2.9 square, say for example, divided by 2, which is equal to 4.41 or 4.42 approximately. So a new center will be minus 4.420, and this as the starting point. Draw an arc. So keep on doing this. So we'll be getting with the phase trajectory for the system. Now what will be the direction of trajectory in the phase plane, that we need to see as well. If we have x1 dot greater than 0, that's actually x2 is greater than 0, because omega will always be greater than 0, will always be a positive number, then the trajectory moves from left to right. Whereas if x2 is actually less than 0, or you can say x1 dot is less than 0, then the trajectory moves from right to left. Fine. Or you can also say if x1 decreases and x1 dot is x1 decreases, then the trajectory moves from right to left. So for x1, for x2 greater than 0, trajectory moves from left to right. For x2 less than 0, that trajectory moves from right to left. Or in other words, this is actually the variation of x1, the change in the rate of change of x1. x1 dot can either be less than 0, x1 dot can be greater than 0. Greater than 0, this means left to right. x1 dot less than 0, this means from right to left. Or you can say x2 greater than 0, x2 less than 0. So accordingly, you can see in this particular case what we had is this is actually minus 0.3. So this equation, this will be less than 4.42. This might be 4.3, something around that. You have to recalculate this. So for this particular case, x2 is actually less than 0, and therefore the trajectory will move from right towards left. So this is about the phase plane analysis. You can also construct the phase plane for this system using delta method. You can try this. We have an equation x double dot plus 4 x dot x plus 4x equal to 0. So what you can do is you have to get it in this form: x double dot plus 4 x plus x dot x. So this is actually comparable with x double dot plus omega naught square x plus delta equal to 0. So in this case, omega naught square is equal to 4, that's omega naught is under root of 2, and your delta here is modulus of x dot into x. So you can therefore draw the arc, you can find out the center, and you can draw the phase trajectory for the system. So we'll continue next time.